Hey guys, I'm gonna go through the 2B test review. I think you guys will find it useful if you're doing this at home and struggling on some of the questions. So question one, you'll see in Alex right here. So we've got Goran, cool, buys cheese from a local farmer's market. The graph below shows the cheese cost in cents versus its weight. And so what's asking for part A says how much does the cost of cheese increase for each ounce. So if you just look at the graph right here, so for every ounce you increase, so from if you go to 1 ounce, 2 ounces, you can see that you go up 66 ounces. So when you go over 1, you're at 66. When you go over 2, you're at 132. So that's an increase of 66 cents for every one. So you're just looking at the slope right there. And then what is the slope of the line? Well, that is the slope of the line. The slope of the line is an increase of 66 for every 1 unit. And so don't put 1 over 3. That would be incorrect. The slope would be 66 as well. And we can check it, and we got it correct, okay? So feel free to try more of these right here if you need any help. All right, to question 2. I'm actually going to take a screenshot of this, and I'm going to work on this right here in Notability. So let me actually do that in here. Okay, so looking at it here, we've got the monthly cost in dollars of water use, and it's a linear function for the amount of water. So whenever we use water, that's measured in 100 cubic feet. This is how much it costs. So the cost for using 14 of these right here. So what I'm going to do as I go along is keep note of these right here. 14, 13, 62. So I'm just going to make a point. I know it might not be accurate, but this point right here would be the point of 14, 36.62. And then for 31, so I'll put this one over here. So at 31, so we'll call this 14, we'll call this 31. So this would be the point 31 and then 66.37. So we have two data points on this, but what is the cost for using 29? So 29 would be somewhere like maybe like right here. So I know that this is 29, but I don't know what the cost is right here. So what I'm going to do is I'm going to find the slope of the line using these 2 points. So if I have 2 points, I can find the slope of the line. So we do that by using the slope formula. So the slope formula says you take the y value of one of the points, so that would be 66.37, and I would subtract the other y value, so 36.62, over, now I'm going to subtract the x value, so 31 and 14. So, 31 minus 14. So I'm going to calculate this in a calculator. I'm going to find out what the slope between those 2 points are going to be. So we're going to do 66.37, subtract 36.62. Okay, and then for that I get 29.75 over 31 minus 14, which will be 17. So I'm going to divide those, so 29.75 divided by 17, and I get a slope of 1.75. So that's how much for every 1 unit that I increase. So every 1 HCF, I increase $1.75. Now, I just have to work my way backwards from this point or forwards from this point in order to get the y value here. So I'm going to work forwards from that point because I work better when I work forwards rather than backwards. So I go from 14 to 29. So how many water usage is that an increase of? So 29 minus 14 would mean 15. So I increase right here, I increase by 15 on the x. So on the x I increase by 15, but how much do I increase on the y? So to see how much I increase on the y, what I'll do is I'll take my rate of change, my slope, and I'll multiply that by 15, and so I'm going to multiply, but then I'm going to add that to my y value right there, and that will give me my y value for the next point. So again, I'm going to multiply these together, so 1.75. I'm going to multiply that by 15, so slope times by this right here. And when I multiply these together, I get 26.25. And then I'm going to add this to 36.62. And I get that that's going to be equal to 62.87. That's how much it's going to cost for 29 of those hundreds of cubic feet. So that's how much it's going to be, 62.87. So 62.87. There you go. Okay, so that's how you'll do that one right there. For question 3, looks like we got some piecewise functions. So I'm going to take a little screenshot right here of this right here. Okay, and I'm going to delete all that right there. All right, so this is for my number 3. So I'm going to graph it here first, and then I'll graph it in Desmos. So graphing it here. So piecewise functions, so these are the y values. So this is a step function. Whenever you just see numbers and no variables here, it's a step function. So we're going to have -2 from -2 to -1. So -2 is right here. And then we're going to use an open circle for the left side of the line segment and a closed circle on the right side of the line segment. So -2, starting at -2 on the x, and going to -1, so that'd be closed right here. So that would be the first step. So you can see the y value is -2, the y values are -2, from -2 to 1. So from -2 to -1, so that should be the extent to which my line is. And then the next part is -1. So that would just be one value above it, but I only want it from -1 to 0, open on the left, closed on the right. So open on the left, but closed on the right. Okay, the next step will be 0, open on the left and close on the right from 0 to 1. So 0 from 0 to 1, like that right there. And then we'll have 1, so that would be here, but from 1 to 2. And then we'll have, again, open on the left and closed on the right, just like that right there. Okay, so you'll go in here. So we'll have it, if it will let me move this, so -2, starting at -2. So we'll put an open circle there. We will, if it will let me move it, we'll put a closed circle right there. Okay, and then we'll use the line segment. We'll place the first dot here, the first one there. Okay, and then we'll repeat this for steps. So we'll move that right there. And then we'll put this right here. Do a line segment from here to here. Open circle here. Close, close circle there. Do a line segment from there to there. Open circle here. Close circle here. And do a line segment from there to there. Let's go ahead and check it. And we're good to go. Now I am going to try another one because there are different variations of this right here. So this would be a good one to do. Yeah, because this one will have a point, not just a line. So let me go ahead. Give me another screenshot of this right here. And let me graph it in here. So delete that. Throw this in right here. Okay, and let me erase all this right here. All right, so for this one right here, kind of following the same thing. So we're going to have 2, but this isn't going to be like just a line segment where one side is closed and one side is open. In this case right here, this will be a ray because we want it to be less than 0. So we have 2. So 2 should be a line like this right here, but it should be closed. It should be open right here. And then it should be continuous going to the left right there. So you should have a closed circle here, and your line should be going like that right there. So it's not going to be a closed line segment, or not just going to be a singular line segment like this right here. This one keeps going for less than 0, always like that. Okay, I'm going to jump down and do this one next. So we got -1 here. So this is going to be at -1, so that should be a line like this, but this should only be on the right side. Whoops, I don't know why I did a closed circle right there. That was open circle. So open circle, and then open circle here, and then this one will be going to the right because it's greater than. And then at -2, so that would be right here, but this one's not going to be a line because it said because it says it should be -2, but only at x equals 0. So this should just be a closed circle right here. So at x equals 0 and y equals -2, it's just going to be a singular point. So whenever you graph that in here, so we'll do an open circle at 2, and we'll also do an open circle at -1. You'll grab the ray line, and let's move it accordingly. And then we'll grab another one like this right here. We'll grab a point, but we'll put the point right here. Let's go ahead and check it. And there you go. There might be one other variation I want to go over, just because I want to make sure that you guys know how to graph it, because I was kind of having troubles formatting how you're supposed to graph it. This is it right here. So I'm just going to do this one in here. So you can see it says g of x is equal to 2 when x is not equal to 0. So this means I'm going to take the line and I'm going to draw a line at 2. Right there. Okay, so there is a line, and it's a line at y equals 2, but it says x cannot equal 0. So that means I'm going to grab the whole, and then at x equals 0, along that line, I'm going to place the whole right there. So that's what it should look like. So this is where a line that looks like 2, but not at x equals 0. And then I'll grab a point, and then I'll put this point at -4, and then only at x equals 0. So that's what this should look like. So you'll do check, and there you go. You got it. So that should cover all the variations of that type of problem. All right, let's try 4. All right, so for 4, right here, we have another piecewise function. This one is not going to be a step function, or it's not going to have those horizontal lines, or it might, but not likely. So these ones are just going to consist of sloped lines. So let me go ahead, take a screenshot of this right here. And I'll put this one on number 4. Okay, so we're graphing these linear lines. Honestly, you guys should know how to do this by yourself because linear lines are something you've been covering since SM1. So here we have 2 sets of lines. We have a y-intercept at -2. So at -2, I'm only going to put an x. I'm going to put like an x right here because I might have to erase the part of the line. So x equals -2. And it's going to have a slope of 1. So it should look like this whenever you plot some points. So notice I'm just putting x's here because that just indicates where the line is going to go. So there should be a line like this right here. Okay. Now, this is why I only so like for this right here, this is the part where we can't ignore. So at x equals -2, that's where this line is going to stop. So either the line is going to go like this. So -2 is where it's going to stop. So this point right here should be the last point. But you have to decide if it's going to be this way, like that, or if it's going to be this way, like that. And that depends on if it's less than or if it's greater than. So if it's less than, I'm going to draw it like this right here, where the end is going to be at -2, but it's going to continue to the left. And because it's less than and not less or equal to, that means I'm going to use an open circle. So I should have an open circle right here, and my line should go just like that, and I don't need these right here because I only want to draw it to the left of -2. Okay, now we're going to do the same thing here. This one has a y-intercept at 2. So we should have a point right here, and we're going to have a slope of 3. So over 1, up 3, over 1, and up 3, down 1, over 3, down 1, or over 1 and down 3. So right here. So it will actually connect with this one right here. And because it's a closed circle, it'll be closed right here. And because it's greater than, you'll draw it to the right, just like that. So that's what our graph should look like. So while I'm going to put a closed dot, we're going to put that closed dot. So I'm going to go over 1, down 1, 2, 3, over 1, down 1, 2, 3, just like how I graphed it before. You can use this pencil, and the pencil will put a marker, and it won't put a point, it will just put a marker. So that way, whenever it will just help you put in your points right here. So just like that. And then for the other line, we'll have this right here. And remember how it connected, but this one just had a slope of 1. So it should just look like that. Now it's asking if the function is continuous. So this one is going to be yes because the lines touch at that corner right there. So we'll go ahead and check it. Uh-oh, I have something wrong with this right here. So at -2, -4. Oh, whoops, I think I went too much right there. So -2, -4. I have this in the wrong spot. Can I just tap that right there, or am I gonna have to delete stuff right here? So over 1, 2, 3. Yeah, no, I definitely did not put those in the right spot. Sorry, let me do that one more time. This is why the pencil is nice. So we should have it should be right here. 1, 2, 3 over 1. 1, 2, 3 over 1. And then it should be 1 like that right there. So I think I got it. This point should be right there. And there we go. And another one should be just like that right there. Let's see if I get it right now. There we go. Sorry, I had it down just one too many. All right. Okay, so there you go. If you need to try more, just keep trying more. Note here, so let's say, for example, that this was slightly down a little bit more, so something like this. If you have a case where they do not touch, so notice how there's that gap right there, that would mean that the function would not be continuous, so you'd put a no for that. Okay, but yeah, practice those ones. All right, for 5, you're finding the average rate of change. So in this one, you're trying to find the average rate of change from x equals 0 to x equals 4. Let me go ahead and take a screenshot of this. It'll be useful. Basically, all I'm going to do for this one is just calculate or count the slope between the points that I have. So what I would do here, so we said at x equals 0. So at x equals 0, we're talking about this point. And then at x equals 4, we're talking about this point. So what is the slope between these points right here? So what is the slope? So I can see that I'm going over 4. And since I'm at y equals 1 and this is 16, that means it should have a rise of 15. So this average rate of change should be 15 over 4. So I'll type that in here. So I need my keyboard. Unless it will do 50, nope, I need a keyboard. Show keyboard. 15 and 4. Let's go ahead and check it. There you go. So you'll just count the slope between the 2 points that are given. For this one right here, so we have 3x squared minus 8x. So this is for number 6. We have 3x squared minus 8x, like that right there. And from x equals 1 to x equals 6. So this time we don't have a graph. We just have x values and a function. So note the x values are, we're just using the average rate of change formula. So y2 minus y1 over x2 minus x1. Except we're not doing it visually this time with a graph, we're doing it algebraically with a function. So these are the x values. So we have x2, we've got x1. So I know that I'm going to have to do 6 minus 1 on the denominator. And now I have to find y2 and y1. I will plug these in respectively for x2 and x1 in order to get them. So I can plug in 6 right here. So I get 3 times by 6 squared minus 8 times by 6. So we can go ahead, plug that into a calculator. That's going to be 3 times by 36 minus 8 times by 6. And I get 60. Minus, now I'm going to plug in 1 right here. So it's going to be 3 times by 1 squared minus 8 times by 1. So that's just going to be 3 minus 8, which is going to be negative 5. So that's going to change that to be plus 5. So I'll get 65 divided by 5. So I get 13. Let's see if I'm correct. Okay, there you go. And that's how you do 6. So if you need to try more, just keep trying more. All right, let's go to 7. All right, this one has context. So the number of bacteria in a culture increases rapidly. The table below shows N of T, the bacteria, a few times in hours after the moment N equals 1,000. So find the average rate of change for the number of bacteria from 3.1 to 6.2. So you're just going to use the values in the table here, and you're going to use the same formula. y2 minus y1 over x2 minus x1. So for 3.1 to 6.2, so if I look at the table, I see the y value is 2612. So I'll take 2612, and I am going to subtract the y value at 3.1, which is 1589. Okay, and I've got 1023. Then I'm going to divide that number by 6.2 minus 3.1. And I get 330. So 330 will be the average rate of change there. And then you'll do the same thing for part B. It just gives you a different time interval. This time it's from 12.4 to 15.5. So I'm going to take the y value at 15.5, which is 64.25, and I'm going to subtract 4,100, and then I get 2325. I'm going to divide that by 15.5, subtract 12.4. And I get 750. Go ahead and check it. And there you go. So those are all just average rates of change. All right, for 8, we've got some systems of equations. Okay, let me go ahead and put this in here. Okay, this is what I'm trying to solve. So this one is specifically wanting you to do it by substitution. Now, if it asks you to solve through substitution, that probably means that it's easier to solve through substitution. And this is why. Get it? It's y. There you go. So what we're going to do is we're going to take this 2x minus 1 and we'll substitute it for the y in the equation above. So 3x plus 4 times by 2x minus 1 equal to 18. So 3x plus 8x minus 4. You have to distribute the 4. And then we'll combine like terms. So this becomes 5x when you add those together. Minus 4 is equal to 18. And then I'll add 4. So 5x is going to be equal to 3x. That's wait a minute. That's not 5x. I'm not subtracting them. That is going to be 11x. Sorry, 11x is going to be equal to 22. I'm going to divide by 11. Divide by 11. I'll get x is equal to 2. And then I just need to plug this in back here. So 2 times by 2 minus 1 is equal to y. So 4 minus 1 is equal to y. So y should be equal to 3. So I get x equals 2 and y equals 3. 2 and 3. We can check it. And we're good to go. All right, for question 9, this is a 2-variable, 2-equation system, but this time you can solve this one through elimination. You can probably solve this one through substitution, but I would recommend elimination, but up to you guys. It's really up to you. Okay, this one would be easy to eliminate, but basically what we're trying to do is we're trying to cancel out one of the variables, but in order to do so, they have to have the same number and opposite sign. So these won't cancel if we add them. These also won't cancel. So, but I can always manipulate an equation. So if I choose to multiply this equation by -1, I'm going to get positive 2x minus y equal to -9. And then again, I'll take the equation that's with it. And now, if I choose to combine the equations, those will cancel. So combine them, that becomes 7x. The y's cancel, equal to 12 and 9. So that's going to be equal to negative 21. And then I'll divide by 7. And I'll get x is equal to -3, which I can plug back into one of these spots right here and solve for y. So I'll do the top equation. -2 times -3 plus y is equal to 9. That's equal to 6 right here. And then I can subtract 6 and subtract 6, and I'll get y is equal to 3. So x is equal to -3, y is equal to 3. So we got -3, we've got 3. Go ahead and check it. We're good to go. For 10, we have a 3-variable equation and three equations. All right, we'll put that here. Okay, now this one is an easy substitution. All I have to do is pick the equation that it gives you something really easy. I'm actually gonna I don't know. I'm gonna try and get something a little bit more difficult. Oh wow, I got one of these right. So for example, something like this right here. Notice the top equation is -2z is equal to -4. I can easily divide that top equation and find that z is going to be equal to 2. And that's what I would start with. This one's just really easy. Y is equal to 1. I'll plug this in here, but I can't use this equation yet because I don't know what z or x is. But I can also plug the 1 in right here, which is useful because then I can solve for x. So if I plug that in right here, I'll get -2x plus 1 is equal to 3. Subtract 1, subtract 1. -2x is equal to 2. Divide by -2, divide by -2, and I'll get x is equal to -1. Okay, so now I have y is equal to 1, x is equal to -1. like I said, you can plug the 1 in right here. Now I can plug the negative 1 in here. So I'll get 3 times negative 1 minus 2 times by 1 plus 5z is equal to 5, which allows me to solve for z. So this is negative 3 plus 2 plus 5z is equal to 5. I can combine those. That's going to be negative 1. Right? Plus 5z is going to be equal to 5. I feel like I'm doing something wrong here. Y is equal to 1. X is equal to negative 1. That's equal to 5. 1 second, something smells fishy here. Starting from the beginning. So y is equal to 1, so negative 2x plus 1 is equal to 3. So I'm going to subtract 1, subtract 1. Negative 2x will be equal to 2. Divide by negative 2, divide by negative 2, and I get x is equal to negative 1. So I'll plug that into the top equation. So 3 times negative 1 minus 2 times by 1 plus 5z is equal to 5. So this would be negative 3 minus 2. There we go. That should be good. Plus 5z is equal, I don't even know what I had before, but this will be equal to negative 5 plus 5z is equal to 5. And then I'm going to add 5 and add 5 here. So I get 5z is equal to 10. Divide by 5 and divide by 5. And I'll get x is equal to z is equal to 2. And that's what you would have for all your solutions right there. That would be good. Cool. For 11, now 11 should be kind of like a... Oh, this one's a more difficult system of equation. But still something that we can do. Okay. All right, so let's work through this right here. What we want to do is solve this one by elimination. So we want to try and cancel out x's, y's, or z's. So I think I'm going to cancel out x's. I can kind of see that that's kind of an easy target right here. But remember that you have to commit to eliminating x first for all of them. But if I chose y, I would have to commit to y. If I chose z, I would have to commit to z. So I'm going to commit to x. I'm going to take the first two equations, 1 and 2. And this is how I like to organize my work. So 1 and 2 meaning I'm going to combine them. So that's going to cancel to be 0. This is going to combine to be positive 2y. This is going to combine to be positive 3z. And this is going to combine to be positive 1. Okay, so this right here is a new equation. We'll come back to this in a second. But now I'm going to go back to these three equations. So I picked 1 and 2. Now I have to pick a different two equations to eliminate x again. So I think I'm going to pick 1 and 3. Now the thing about 1 and 3 though is that when I add them, again, I have to commit to getting rid of x because that's what I got rid of here. But when I add these two together, 1 and 3, I'm not going to get rid of x because this is 2 and this is negative x, so that won't get rid of them. Meaning, I have to multiply this equation by 2 in order to get this to be negative 2x, then it will do that. So let's multiply this by 2. Well, I'm actually going to write out the first equation first. So the first equation being 2x plus y plus z equal to negative 3. And I'm going to multiply this by 2. So we get negative 2x plus 4y plus 2z equal to 10. So multiplying that by 2 results in this right here. Now I can combine those, and that's going to become 0. And then I'm going to get 5y plus 3z equal to 7. this is a new equation 2. So I'm going to put these right here. I'm going to stack these together as a new system of equations. So my new system of equation is going to look like 2y plus 3z equal to 1, and 5y plus 3z is equal to 7. And now I'm going to treat this system of equations just like I treated it with the 1 all the way up here, like that, where I'm going to get rid of either y or z. So this won't be too hard. In order to get rid of the z's, all I have to do is multiply one of them by -1. So that's going to be negative 2y minus 3z equal to -1. And then I have the 5y plus 3z equal to 7. So those are going to combine. That's going to give me 0. That's going to give me 3y is equal to 6. Now I can divide by 3 since y is by itself, and I'll get that y is equal to 2. So there is the first part of my solution. Now I'm going to use this right here and plug it back into one of these two new equations. So either new equation 1 or new equation 2. It doesn't matter which one. I'll plug it into, let's say, the second one, because that's the one I can easily see. So I'm going to do 5 times by 2 plus 3z is equal to 7. So 10 plus 3z is equal to 7. I'm going to subtract 10, subtract 10. I get 3z is equal to -3. Divide by 3, divide by 3. So I will get z is equal to -1. And then I'm going to steal one of these original equations where it has x in them, and I'm going to plug in these values right here. So I'll take the -x, I'm going to write it first up here. So -x plus 2y plus z equal to 5. Oops, okay. And I'm going to plug in values. So -x plus 2 times by 2 minus 1 is equal to 5. So again, I'm plugging in -1 here, plugging in 2 right here, and then I can solve for x. So -x plus 4 minus 1 is equal to 5. So -x plus 3 is equal to 5. I can subtract 3 and subtract 3. I get -x is equal to 2. And then I'll divide by -1. And I'll get x is equal to -2. So that's how you'll get your 3 answers for this one right here. Okay. All right, let's try 12. Okay, so 12 is going to be a systems of equations, but we're using, we are using, we need context, so this one's going to have a story problem. I'm going to go ahead and clear this right here. Okay, so all right, I'll just show you how to set this up and how to solve it. So notice here that we have Kira, Dion, and Brian. They have a total of 98. So we're trying to write this as a systems of equations. So I'm going to write this as K plus D plus B is equal to $98. And then here it says Brian has has 2 times what Dion has. So for me, that says B, Brian has twice the amount of Dion. So Brian's money will be equal to twice the amount that Dion has. And then the other one says Dion has 10 less than Kira. So I would say Dion is going to be equal to Kira minus 10. So Dion has 10 less than Kira. So 10 subtract what Kira has. Okay, and then how much do they have in their wallet? So we're trying to find for how much K, D, and B is going to be equal to, and that just represents how much they each have. So mathematically what we could do is just start substitution. So we can substitute this 2D for this right here. So I would have K plus D plus 2D equal to 98. But this still isn't quite useful because I have the K right here. So I can simplify this to be K plus 3D is equal to 98. But I can't solve for anything here because I have two variables. But I could also go here, and if I switch things around, I could say that K is equal to D plus 10. Well, that means I could put this for the K. So if K is equal to D plus 10, this is D plus 10 plus 3D equal to 98. Now everything either has a variable D or a constant, which means I could add these together to get 4D plus 10 is equal to 98. And then I could subtract 10 over here. So I get 4D is equal to, that would be 88. And then I could divide by 4. So 88 divided by 4 is going to be 22, yeah? So D, how much does Dion have? Dion is going to have $44. Okay, well, if Dion has $44, Brian has double that amount. So we just have to multiply that by 2. And that, 44, right? Wait a minute, yeah. Sorry, that's not 44. That's 22. 22, yeah. So Dion has 22. So that means that Brian would have to have 44. So Brian would have to have 44. And then Kira has 10 more than Dion. So that should be 32. So K should be equal to 32. And you can add those together. 44 plus 22 plus 32. And I get 98. So I think that should check out. So Dion, 22. We said Brian has 44. And then we said Kira has 32. Go ahead and check it. And there you go. All right, now for the rest of the assignment, this should mostly be on paper. So that's going to be through all of that right there. So I'm actually going to close the video here, and I'll do a separate video for those ones.